This is Algebra 2 with Trig, 6C.1a. We're working with properties of logarithms. So the main thing we're focusing here is the product property. Here we have a logarithm. This logarithm has base b of a value, and this value can be broken down into two factors. Now, a property of logarithm tells us that we can separate those two factors into two separate logarithms by addition. If you think about the rule like x squared times x to the third, we're multiplying the same base, so we add the exponents. So thinking about logarithms as being exponents, and here we're multiplying, that might help remind you that you are adding logarithms. And here we have a fraction. So what are we going to do with our two logarithms? We're going to use subtraction. Into our next one. Here is an exponent. N is an exponent. So we can write this exponent and bring it to the front. So it would be n times log base b of m. So those are your different properties that we'll be working with when the b value is greater than 1. So we're going to use those properties to work with these situations. Notice that they're giving us some information. Log base 5 of 4. Log base 5 of 4 is 0.861. They're telling us that 5 to the power of 0.861 is approximately 4. We're going to use that knowledge and the fact that log base 5 of 9 is approximately 1.365. We're going to use those two facts to help us simplify and calculate what these would be. I don't know what log base 5 of 4/9 is, but if you notice, it's a fraction, so we can break this apart as log base 5 of 4 minus log base 5 of 9. We took one logarithm and we wrote it into two logarithms. Now we have it as log base 5 of 4. So we can substitute in the 0.861 minus 1.365. And using our calculator, 0.861 minus 1.365 gives us negative 0.504. So we were able to calculate that. Essentially, we didn't use a calculator. We just did it to help ourselves work with decimals. But we weren't using logarithms in our calculator. We showed our step how we used our property to help calculate our negative 0.504. This one. This one's not as clear. This one's 4 divided by 9, and we needed 4s and 9, so that was pretty clear. This one's 36. So how can we work with these facts using 4s and 9s? how can we rewrite this 36? 4 times 9 is 36. Some people ask, can we use 3 times 12? Well, mathematically, you can use 3 times 12. That's 36. 6 squared is 36. But we don't have 3s and 12s or 6s. We don't have that information. We have to use 4s and 9s. So because these are multiplied, we can break it apart into 4 plus log base 5 of 9. So this is 0.861 plus 1.365. 0.861 and 1.365. We get 2.226. So notice what we did. What you're asking yourselves, why did we break 36 down into 4 and 9? Why not use a different set of factors? There's lots of them. 2 times 18 is 36. And then we broke it apart with addition. So we could write 2 logarithms that we knew their values of. Okay, what do you see down here with number 3? What choices are you making? Everyone should have an opinion. You can do 9 times 9. That is definitely a good way to do it. What is another way to write 9 times 9?
9 squared.
9 squared. Just so we use that property. Because 9 times 9 is going to look just like this property where we separate it with addition and we add 2 numbers together. It totally works. You'll get the answer. If you think about 9 squared is 81, then we're going to be able to use that property to bring the 2 in front. And we know that log base 5 of 9 we're going to have 2 times 1.365, and that gives us 2.73. Notice that 2 times log base 5 of 9 would be the same thing as log base 5 of 9 plus log base 5 of 9, which would happen if you said 9 times 9. So the result's the same. So you go ahead and try to set these up. We know that log base 6 of 5 and log base 6 of 8. Pause the video, give this one a try, then I'll walk you through it. Since we have a fraction, a logarithm of a fraction, we can break this into 2 separate logarithms, which we have 0.898 minus 1.161. So 0.898 minus 1.161 gives us negative 2.63. Notice we did not use a calculator to answer this question, except to group our decimals together. On this one, we're looking for factors of 40. We could use 2 and 20, 4 and 10, 5 and 8. 5 and 8 works really well because we know what log base 6 of 5 is and log base 6 of 8. So we need to use 5 and 8. And if you're doing the logarithm of a product, we can separate those products using addition. So that's 0.898 plus 1.161. And that gives us 2.059. Then over here, we're looking for ways to multiply it to be 64. We could use 2 times 32, 4 times 16. But you could also use, but we don't have 4, we don't have 16, so those aren't working. So we would need to use some sort of 8 times 8. And if you want to write 8 times 8 and break it apart into 2 logarithms adding to each other, you can. That's totally fine. I like to use the power property, where I can write that power in front. So it's 2 times 1.161. So that's 2.322. Let's test that theory. 1.161 times 2. There it is. All right, down to the exciting examples. Expanding and condensing. You've got to use your brain. You've got to put the puzzle together. When asked to expand, we use properties of logarithms to break down logarithms into a simpler components. In your final answer, each term should be in simplest form. There should only be one factor. There should be no exponents. Okay? And there can be multiple logarithms. You will have multiple logs. There's another term called condensing. When asked to condense an expression with the same base, you must have the same base, we do the reverse. When condensing, our final answer should only use the logarithm once. You only have one logarithm. You go from multiple logarithms to one logarithm. If you go from one logarithm to multiple, that's expanding, and condensing is when you bring it down into one. So expanding is kind of like factoring, breaking it apart into multiple parts. And condensing is kind of like multiplying, and you condense it together. So here we're looking at it. The first thing that we want to focus on when expanding is, do we have a fraction? That's the first thing that you really notice here. That you have a top of a fraction and a bottom of a fraction. So if you have a fraction, we know that we can break that fraction up using subtraction. Now we don't have a fraction, but we have addition. But we have multiplication. So we're going to break that multiplication up using addition. And we still have the minus log base 3 of y to the fourth power. And here we feel pretty good. We've done all the different parts. But if you read back at the notes, it said no exponents. So we know that we're going to bring this 4 and put it in front. But how about this x? Could this x, which is the square root of x, could this be written with an exponent? What's the exponent that would replace the radical sign? What's the exponent? We would square it if we were thinking about getting rid of it. If you had an equal sign, you could square both sides. That's how you get rid of. But we're not getting rid of it. We're just going to write it with a rational exponent. What's the fraction that represents a square root? That would be x to the half power. The half power implies that that is taking the square root of x. Now we're going to write both of our exponents in front of its own logarithm. That's the important part here. It goes in front of its own logarithm. So our final answer is log base 3 of 7 plus half log base 3 of x minus 4 log base 3 of y. Now some people ask, oh, you have a fraction. Should we separate those numbers with subtraction? You've never subtracted, you've never done that with other fractions. So you won't do that for this fraction. We only do it if we're taking the logarithm of a fraction. There's a difference. This isn't the logarithm of a half. This is half times. All right, let's try it again. Here we have a logarithm of a fraction. So we're going to write it into two logarithms using subtraction. Each of these logarithms have two factors. So we're going to separate those using addition. But you have to be careful because we're subtracting this logarithm. To subtract this logarithm, you've got to use parentheses. Here we've separated the 4 and the x squared using addition with two different logarithms. Now we know that the exponents will go in front. So this is log base 7 plus 3 log base y minus, now let's think about how we would work with this. We would distribute it to the first logarithm and we'll distribute it to the second logarithm. We'll do this all in one step. So this is log of 4, that's a common log. Negative times a positive is still a minus because you're minusing both the 4 and the x squared because they came from the denominator. But the 2 is going to go in front and we'll call it log of x. There's your answer. You want to understand what you have to the level that you could explain it to somebody else. If you don't know where something came from, whoa, this is really confusing, then back up, watch this portion again, try to understand how we broke it apart. I walked you through every step. Try to get a good understanding. Try a homework question. Come back, watch the video if you need to. Now we're condensing. That means we're going to take multiple logarithms and turn it into a single logarithm. So we're just going to go in reverse order. Before we looked for the fraction, so we did subtraction. Then we looked for multiples, so we did addition. Then we finally worked with the exponent. So now we're going to go in the reverse order. We're going to bring our exponents up first. So we have log of 2 plus log of 3 squared minus log of 9. That should be, not squared, sorry, that should be 3 to the third power. I'm sure you noticed. So this is going to be log of 2 times, because we have addition, times 3 cubed. What is 3 cubed? 27. Minus log of 9. Because we were adding two logarithms together, we're going to bring that 2 and the 3 cubed together. You can call that 54 if you want. That's fine. Log of 54. Minus means make a fraction. Don't write the logarithm twice. That actually means something else. We'll do that soon enough. We're only writing the log once for this fraction. And this, of course, can simplify into log of 6. Now notice these are all common logs, a base of 10. So we could test this in our calculator, that the log of 2, you got to close the parenthesis, plus 3 log of 3, got to close the parenthesis, minus log of 9, you can close the parenthesis if you want there, it's going to give you some decimal. We don't care about the decimal. We got our final answer. Log of 6. I'm expecting that to be the same exact decimal. And that's a way that you can test your if your answers are making sense. If you don't have variables and the bases are easy enough to work with, that works out. Okay, let's try this one. I'm looking through it. I'm looking for any exponents. This guy here is going to be an exponent. So it's the natural log of 3 plus the natural log of x squared minus the natural log of y. Try to do this one on your own. You can pause the video, calculate this one up, see how you did. Because we have addition, we're going to say the natural log of 3 times x squared minus the natural log of y. When you're subtracting two logarithms, now pay attention to this closely, when you're subtracting two logarithms, you're only going to write the log one time and you do a fraction. So natural log of 3x squared over y. We would not, it's not even correct to write our exponent in front of this because it wouldn't go in front of the 3. It would only go in front of its own logarithm, like up in here. So there's nothing else we can do. All right, here we are. We're talking about a change of base formula. How do we handle doing some calculations when we're in a different base? Well, there are two ways. One, there's a calculator method, when it's appropriate to use a calculator, your calculator can actually do the base for you. But there's also a mathematical way, so want to still be sure that you understand that. Notice here that the B looks to be lower than the M. The base is lower. So we're going to write our change of base. So we're going to call this log of M over log of B. Our base, just to be convenient for ourselves, being a 10, because we have that in our calculator. Our calculator might not be able to change the base, but if we write our fraction, it's pretty crazy how this works. If we have, what's something that you know? Log of 2, log base 2 of 8. What is that final answer? What is log base 2 of 8? It's going to be 3. So what we're going to do, we're going to write this as log base 8 over log, not base 8, sorry, log of 8 divided by log of 2. And we can go to our calculator, and we can say log of 8, close the parenthesis, divided by log of 2. And we hit enter, and you get 3. So you can do the calculations with bases even if the only calculator log key that we have is log. Now, oddly enough, we have ln also. And this is going to be the natural log of m over the natural log of b. The base can be any number you want. So we can try it. Natural log of 8, close the parenthesis, divided by natural log of 2, close the parenthesis if you wish, and hit enter. You're going to get 3.
Did you put one of them as ln and one of them as log?
No, your bases need to be the same when you do your calculation. Now, okay. We have fancy calculators. What can our calculator do for us? Let's see if we can find it. There's 2 different ways. If we go to the math key, and I'm scrolling upwards, I get to this log base option down here at letter A. And you can see that it gives you a spot to type in the logarithm, and it gives you the spot to type in what you're taking the log of. So if we put our 2 in that spot and our 8 in that spot, we would still get 3. So now you know it can be done in a calculator also. So that means whenever there's a possibility that you are getting answers from your calculator, you need to be sure to show those steps. So let's try this. We're trying to calculate what is log base 6 of 11. Well, one way we could do it is log base 11 over log base 6. This is where you write the log twice. Very important to write the log twice. Log 11, close the parenthesis, divided by log of 6. You can close it if you want to. And you get 1.33. Tenths, hundredths, thousandths, we would look at the 10,000s to determine that we'd keep our 8. And the other method I showed you is that you could go to the math key, you could arrow up, and you go to the A to get to log base, and you could do your 6, you could do your 11, and you should get the same exact decimal. If you're using a calculator, you're using a calculator. I don't mind which method here that you use. Change the base or using the calculator. Here, log of 15 over log of 3. Now remind, you cannot call that log of 5. Not log of 5. Log of 15, close the parenthesis, divided by log of 3, close it if you want to, and you get 2.46. That means 3 to this power equals 15. 3 squared is 9. 15 is bigger than 9. 2.4 is bigger than us squaring it. So we know this answer is bigger than 2, but it's less than 3 because 3 cubed is 27. So that makes sense to us. 2.465, because that decimal would go up 1. And we can also use the math key and arrow up twice to get to logarithm, or you can arrow down, doesn't matter. And we did 3, we had 15, and that came out to be the exact same decimal. All right, last one. For a sound intensity, which is considered watts per square meter, the loudness of a sound, which is measured in decibels, is given by this crazy looking equation where I of O is the intensity of a barely audible sound. And we're always going to use 10 to the negative 12 for that I to the 0. 10 to the negative 12. The intensity of an electric guitar is 10 to the 2.8 power. Those are watts per square meters. What is the loudness? What is the measurement of loudness? So we're trying to figure out the loudness, which is L of I (10 to the log of our sound), which is 10 to the 2.8, divided by the the inaudible sound, 10 to the negative 12. Now, without several of these that you end up doing, you can do these calculations without a calculator. Let's see if we can handle these without a calculator. How do we handle this? How do you simplify that? Think about what you're doing. Don't worry about the rest. Your bases are the same, so what do we do with the exponents? We're going to subtract, because it's division, 2.8 minus the negative 12. Well, 2.8 minus is actually adding. So this is 2.8 plus 12. That's going to be 14.8. Now, without a calculator, what can we do here? You could, I can take that. you can take this and put it in front of your logarithm. That is so true. So you have 14.8 times 10 times the log of 10. What is the log of 10? The base is 10. If it's not written, the base is 10. So 10 to what power makes 10? 1. So this is a value of 1. Didn't even need to use a calculator to determine that. Times 1. So what is 14.8 times 10 times 1? 148. And these are in decibels. So 148 decibels, and we did that calculation without a calculator.